We all love cars and use them daily. That's why we wanted to bring you closer to some car components. So, beginning with our structure. First, we want to start with the automotive history. Then we will continue with our components, which are divided into 5 topics. First, the combustion engine, then the e-motors, then the transmissions, continued with the exhaust system and the suspensions. Starting with the history of the cars, the first wheel was invented 4000 before Christ. In 1649, the first mechanical car was built. One of the biggest milestones was reached in 1840, with the first vehicle with a combustion engine. In 1839, the first electric car was invented. Carl Benz created the first Blairy car in 1885. Opel started producing the first car on assembly line in 1924. Firstly, in 1933, the automatic transmission was created, and from 1970 till today, human-built cars which are becoming increasingly safer.
After discussing some milestones of automotive history, let's come to some components of the car, like the engine, the transmission, the exhaust system, or even the suspension. First step is the petrol engine. Petrol engines differ from diesel engines in terms of ignition, because they have an external one. Like diesel engines, petrol engines are reciprocation engines, means an up and down movement is converted into a rotation over the crankshaft. Moving on to the combustion, the temperature for petrol engines is in the range of 400 to 600 degrees, which follows in a higher carbon dioxide pollution than diesel engines, but lower nitrogen oxides. So now to the function. But how does a combustion engine work? On the picture shown, here you see the 4 strokes of an engine. First one is the intake stroke, where air with fuel mixture or without enters the cylinder and the piston moves downward, which creates a negative pressure for the air to be sucked into the cylinder. Second step is the compression. The piston moves back upwards and the air gets compressed up to a ratio of 10 or even 14 to 1. Now on to the important step. The air-fuel mixture, or in case of a direct injection, the fuel gets injected shortly before the piston reaches the upper dead point and ignites the compressed mixture shortly after. Because of the following explosion, or so-called explosion, the piston moves back downwards, and that's the time where the piston generates torque. The last step is where the piston moves back upwards and emitting the exhaust gases into the exhaust system, which we will discuss later.
So, moving on to the diesel engine. The diesel engine also works on the self-ignition principle. The efficiency is here from 25 to 45%, and the diesel engine is also a reciprocation engine, which has an up and down movement of the pistons resulting in the rotation. The combustion temperature is from 700 to 900 degrees Celsius, which leads to a higher nitrogen oxide pollution. The diesel engine also have a long stroke, which leads to a higher torque and lower RPMs. The diesel engine operates on the diesel principle, involving the following steps. Initially, air is drawn through an air filter and compressed in the cylinder. Compression occurs solely through the piston without prior air. Fuel mixture fuel is injected, and due to the high temperature and self-ignition of the diesel fuel, there occurs in the cylinder the self-ignition, which drives the piston downward, creating a power by expansion and generating mechanical energy. Finally, the burnt gases are expelled through the exhaust. So, moving on to the e-motors. The e-motors have a way higher efficiency than the petrol engine or the diesel engine. It can have a efficiency up to 90%. The motors are divided in 2 different motors, the asynchronous and the synchronous motor. Here in the top picture, you can see an electric motor divided into two main parts, the rotor and the stator. So, coming now to the work-wise of an electric motor. At first, the rotor is unaffected, and in a vertical position, no current flows through the coil, and therefore the rotor does not yet possess the magnetic field. When you apply an electric voltage, the coil regenerates magnetic field, and the iron core, the rotor, becomes an electromagnet with the north and the south pole. Since the rotor is a rotatable unit, it continues to rotate until the poles of the magnet from the rotor and the stator face each other, and to check this position, it is so called the optimal alignment. The rotor no longer has to rotate at this point to keep the electromagnet continuously rotating. The magnet rotation of the rotor must be reversed. This task is performed by the commutator, which is connected to the coil and where the voltage source is applied. It switches the north and south pole of the rotor. Afterward, the process repeats from step 3. So coming now to a comparison of the both e-motors. The first one is the operating principle. The asynchronous motor is working on the electromagnet and induction, and the synchronous is working on the magnetic field or starting. Now coming to our starting mechanism. The self-starting is in case the synchronous one, and is requiring an external, and the synchronous is requiring an external device. Right. So coming now to the speed control. The asynchronous is influenced by the load, which the synchronous is not influenced, which can hold constant speed of rotation. Coming to the efficiency, the asynchronous have a lower efficiency and the synchronous have a higher efficiency, demanding on the constant speed of the last point of construction. The asynchronous motor is cost effective because it needs fewer components in the construction, which in the other case, the synchronous has a more complex construction and is the more expensive one.
So, we talked a lot about generating power. Now we want to talk about how to keep the engine in the best possible operating point. So, the manual transmission consists in the simplest way of an input shaft, and counter shaft, and an output shaft, which the switching sleeve connecting the gears, loose gears, with the firmly with the output shaft.
Now to our next topic, the automatic transmission. In the top picture you can see the torque converter. This torque converter consists out of two components. First the turbine, and the other one is the pump impeller. So the pump impeller is driven by the engine and is creating a rotating oil flow in the torque converter. The turbine is connected to the transmission shaft and is driven by the oil flow from the pump impeller. Coming now to the planetary gear set, which you can see at the bottom. This is a system of planetary gears that generate various gear ratios.
So now on to the double clutch. Many people confuse this transmission with an automatic one, but it's only a semi-automatic. Actually, it works like a manual one, but it only has two clutches, 2 input and 1 output. Shift the gear changes are done by a mechatronic module. Here you can see the 2 clutches, the 2 input shafts, and one is full and one is around the other, so this one is named hollow shaft. The one shaft takes over the even gears and one the uneven gears. Reverse gear can be on both shafts. The secret of a double clutch transition is that the gears are selected by the same time while one clutch is closed and another is opened. This makes it possible to shift incredibly faster. For example, gear 1 is selected, then gear 2 on the other shaft is already selected, but only with clutch open. When there is a gear change, the clutch 2 closes, and if you're accelerating, clutch 1 opens and the gear will be selected, and so on. So the third gear will be selected. You have in every case the next gear you want selected. This is controlled by a mechatronic module. So now on to the exhaust system. Here we see a flange where the gases come out of the motor going into the flange, then to a catalytic converter, further to a muffler or a silencer which silence the exhaust gases, and onto another muffler or silencer to keep the regulations. So now onto the diesel after treatment system and the three-way catalytic converter. So how you see, the diesel after treatment system is mainly used for diesel cars, and the three-way catalytic converter is used for petrol cars. Basically, so in the three-way catalytic converter you have one reduction and one oxidation. The nitrogen oxides get reducted in this part here, and the oxide molecules went over to this part, and oxidating carbon monoxide to carbon dioxide and unburned fuel to water. In the diesel you need a separate oxidation and reduction. So basically these are the same reactions, like for the same colors, but you need the SCR cut because you need a diesel engine has more nitrogen oxide, so you have to reduct more. Yeah. The last theme for today is the topic suspension. I've divided this part into four types. We have steel springs, we have coilovers, which are adjustable steel springs in height, and we have air suspension, where the spring gets replaced with the air pillow, and we have magnetic ride. It's basically the same like normal damper, but you can adjust it with particles and oil, so you can make the damper softer or harder. So next we go on to the springs. The springs absorb the shocks and starts to oscillate, and the damper has the task to eliminate the oscillation as fast as possible. Mainly for driving aspects, but also for comfort. So that the car has in every situation all four wheels on the ground. Here you see a picture of a damper. A damper consists of a rod, like this one, and this is connected with a piston which has holes in it. So the oil has to go through the piston holes, and therefore the oscillation gets dampened because there's a higher resistance. In magnetic ride you have particles which you can put a current on, and therefore the ride will be softer or harder. So you can change between soft damping and hard damping. So that was our presentation about automotive. We hope you've learned something. Thanks for watching.
So here are still our sources, which you can see on this side, and those